Alright, 16b, here is a partial fractions problem, but it starts off with polynomial division. So I don't actually technically know it's partial fractions yet until after I do the polynomial division, but I have a good idea it might be because the denominator factors. I can factor in x and then the rest of it also factors. So I got the integral of 3x to the fourth minus 12x cubed plus 9x squared minus 12 over x cubed minus 4x squared plus 4x. And I know I have to do polynomial division because the degree on top is larger than the degree on the bottom. I should say larger than or equal to. If the degrees are equal, you also have to do polynomial division. It's just usually then things work out differently. So if I do the division, it's kind of gross. X cubed minus 4x squared plus 4x into this mess, which is 3x to the fourth minus 12x cubed plus 9x squared. I'm going to throw in the 0x too, just because it's nice to have all the powers of x. X cubed times 3x is going to give me 3x to the fourth, so I multiply this by everything. I get 3x to the fourth. 3x times minus 4x squared is minus 12x cubed, and 3x times 4x is 12x squared. I subtract. Oh, I always do this. Oh well, that's fine. I should have made this slightly different, but it's okay. So subtracting this minus this is 0. This minus this is 0. 9x squared minus 12x squared is negative 3x squared, and then I got a minus 12. So we're done with the polynomial division because the degree of the remainder is now less than the degree of the divisor. So what we're going to say is this integral, which I don't really want to write again, is equal to the integral of 3x plus this remainder, negative 3x squared minus 12, over this divisor, x cubed minus 4x squared plus 4x. And so now this is equal to the integral of 3x squared, which is 3x squared over 2, minus the factor of the minus sign, the integral of 3x squared plus 12 over, I'm going to factor this, the x factors out, and you get x times x squared minus 4x plus 4. But x squared minus 4x plus 4 is really x minus 2 quantity squared. So we're going to go to the other side and we're going to do the partial fraction decomposition, which I think I actually started writing slightly differently because I didn't factor out the minus sign. So let's actually factor, let's make these both plus, just to make our lives slightly easier. You can also leave the minuses, it's also fine. Either way. So I've got 3x squared plus 12 over x times x minus 2 squared equal to a over x plus b over x minus 2 plus c over x minus 2 squared. I multiply both sides by the denominator, x times x minus 2 squared. The left hand side, you just get the top. The right hand side, you're going to get a times this. The x's will cancel, so you get a times x minus 2 squared. And you get b over x minus 2 times this. One of the x minus 2's will cancel, so you get b times x minus 2 to the first. And you get c over x minus 2 squared times this. The x minus 2 squareds will cancel, and you get c times x. Now we pick convenient values. X equal to 0 is definitely one of them. Plugging in 0 here, I get 3 times 0 plus 12 is 12. Plugging in 0 here, I get a times negative 2 squared is 4. B times 0 is c times 0. So it looks like a is equal to 3. And then x equal to 2, I get 3 times 2 squared is 3 times 4 is 12. 12 plus 12 is 24. I get a times 0, I get b times 0, I get c times 2. So that means c is going to equal 12. Finally, I need to figure out what b is. I'm going to equate coefficients. On the left hand side I have, and so I always start with the highest one, but you can use any one. I have 3x squared on the left. If I multiply this out, this is x squared minus smaller terms, so I have an a times x squared. I have a b times x, which is a b times x squared. I don't have a c times x squared. So 3 is a plus b, but a is 3, which means b has to be 0. It's always nice when one of them is 0. So we're going to end up integrating a over x plus c, which is 12, over x minus 2 squared. That's our partial fraction decomposition. So that's what this is equal to. So going back to the other side, we're going to replace that with, and a little out of room here, that's okay. 3, so 3x squared over 2 from the integral of 3x. Minus the integral of, what did I just say? It was 3 over x plus, or was it minus? It was plus. We're going to distribute the minus sign, but that's okay. 12 times x minus 2 to the negative second. So I end up getting 3x squared over 2, or 3 halves x squared. The integral of 3 over x is 3 natural log the absolute value of x. And the integral of 12x minus 2 to the minus 2 is, those parentheses right here, 12 times x minus 2 to the minus 1 divided by minus 1. You could leave it like this, or you could simplify. You simplify, let me write it up here. I have 3x squared over 2, or 3 halves x squared. I have minus 3 natural log of x. Natural log of the absolute value of x. And the minus distributes here, but it cancels the minus there, so we just still have a plus, right? Because the minus and minus. I have plus 12 over x minus 2 to the first. Plus c. So that's how you do that problem. Hopefully that's not too terrible.